Today we're going to look at a GE Cafe microwave. We're going to troubleshoot using the schematics as well as the wiring itself with a meter. We'll start with the schematics. The power will start at the line flowing through the main fuse, through half of an inductor, which is a line filter, past a capacitor and a resistor, which are also part of the same line filter. After that, they reach the oven thermostat, the bottom thermostat, the magnetron thermostat, and the primary interlock switch. These thermostats act like fuses, except that they respond to heat rather than current. The oven thermostat is located on the top of the chassis. The bottom thermostat is located on the bottom of the chassis, and the magnetron thermostat is located on the magnetron. This is the bottom thermostat, magnetron thermostat. The oven thermostat is located around the back. After going through the three thermostats, the power will go to the primary interlock switch. This is normally open. When the door is closed and in the proper position, the switch will close, sending power to the high voltage transformer. This is the monitor interlock switch. It's normally closed. Once the door is closed in the correct position, this switch will open up. If the door is open, the main high voltage transformer is shorted. These switches should never be closed at the same time. If they are, the voltage will go through the primary interlock, through the monitor, back to the main board, and it will short the main fuse for safety reasons. The third switch is the door sensing switch. This is a low voltage, low amperage sensor switch. Comes and goes from the main board on this model, and it just tells the computer that the door is shut. Let's take a look at our switches in real life. This top switch is the primary interlock. You can tell because of the heavy black cable, which normally signifies line voltage. This is the monitor switch in this model. The bottom switch is the door sensor switch. We'll follow the line through the thermostats, through the interlock switch, through the high voltage transformer, going around the monitor switch because it will be off, back to the high voltage transformer relay. From there, we'll turn on things like the oven lamp, the stirrer motor, and the fan motor. From there, it will go back to the neutral line, which is the white line. Black line is the hot line. White line is neutral. This is the main fuse. Let's take a look at some of these components using an ohm meter. The main fuse, will read somewhere near 0 ohms. My leads are not calibrated, so they show a little bit more than an ohm. The oven thermostats will also read very close to 0 ohms. If we measure the high voltage transformer, it will also look like a short. It's actually not. But when it's in this state, it's good. The secondary side of the high voltage transformer will also look like very close to an ohm. We cannot measure anything on this side of the high voltage transformer. We don't have any meters that are capable of measuring these voltages. We can check some of the components with an ohm meter, but not while it's live. This would be in the thousands of volts range. Each door switch can be tested using an ohm meter. Plug in the switch, check that it's closed, open the door. The switch is now open. Likewise with the monitor and the door sensor. If you arrive and find this machine without any power, first thing to check would be the main fuse, the oven thermostat, the bottom thermostat, or the magnetron thermostat. If those are all good, check the main board next. If one of these thermostats is bad, the first thing to check would be the main interlock switch and the monitor switch. If either is bad, replace both just to be sure, because if this one goes bad, this one may be months behind. And it couldn't hurt to replace the door switch as well. These switches were probably all produced within the same week, and they've all had the same amount of exercise. So if one goes bad, the other two may not be far behind. If you find that your transformer is good, and you have voltage to the primary but no cooking, the next spot to look would be the magnetron tube itself. There's no way to test it with the tools that we have, so it should just be replaced. The other possibilities could be the capacitor or diode. If one of them is bad, you will normally get a loud hum at the magnetron. If you're not getting a loud hum, your magnetron is your most likely culprit. Those are just a few of the steps that I would use to diagnose a microwave out in the field.